Hi, this is Math Kimchi, and today I will be creating a program that finds the line of best fit, also known as the linear regression equation. Before I make the linear regression part of the program, I'll create the function input to coordinates. What this function does is it receives all of the x values of the set of points, and then receives the y values of the same set of points in the same order as the x values were received. It returns a list of the coordinates of each of the points in the set, and in this illustration, input to coordinates receives 1, 2, 3, 4, 5, and 6. And the first half, which is 1, 2, and 3, is the x values, and the second half, which is 4, 5, and 6, is the y values. And because the y values and x values match, 1 matches 4, 2 matches 5, and 3 matches with 6. And so the function inputs to coordinates will return 1, 4, 2, 5, and 3, 6. First, I'll make input to coordinates taking a variable called inputs. Inputs can either be a list or none, which inputs is automatically set to. If inputs is none, then input to coordinates asks the user for inputs. I'll make it say, if you are done, press enter without typing anything. And this should be in a while loop that runs as long as cont is true. If the input was an empty string, the user pressed enter without typing anything, so I can stop asking for inputs by making cont false. Otherwise, the input will be added to the list inputs, and because in Python, inputs are automatically strings, but the inputs should be numbers, so I can convert input into float, which is basically the same thing as int, but it can be a fraction. After I have the inputs, I have to turn it into coordinates. So first, the program should check if there's an even amount of inputs. It can do this by doing inputs %2 equals 1, and inputs %2 is the remainder when inputs is divided by 2. So if it is 1, that means there's an odd amount of inputs. So I can print that there's an odd amount of inputs, and I'll just end the entire program. Now I'll just have to create a for loop that goes on for the length of inputs divided by 2, because the amount of coordinates is half of the amount of x's and y's. And before the for loop, I should add an empty list called coords, which stands for coordinates, and this is what I'll be adding onto in the for loop, and this list is also what the function input to coordinates will return. I'll make the for loop start counting from 1, or actually the for loop should start counting from 0, because it stops counting before the len of inputs divided by 2. C will be a coordinate, and the 0th element of C is the x coordinate, so it should be the ith element of inputs. C's first element is the y coordinate, so it should be I plus half of the length of inputs, element of inputs. C will be added to coords, and after the for loop, I just have to return coords. To test this, I'll run inputs to coordinates and print what I get. If I type 1, 2, 3, 4, 5, 6, and then nothing, there is an error message saying that it couldn't convert the empty string into a float. And now that I'm looking at the line 11, I see that the program shouldn't even try to add the empty string to inputs, so I'll make it add the float of inputs to inputs if input is not an empty string. If I try this again, I get another error message saying that a float cannot be used as an integer. And this is because in Python, the quotient is automatically set to a float, even if the problem was something like 4 divided by 2. And this is an easy fix because I just have to set len of inputs divided by 2 as an integer in line 17. And while I'm at it, I'll do the same in line 18. If I test this again, it's all working. The reason why it says 1.0 instead of 1 is because it is a float. And if I wanted to change this, I could just pass 1, 2, 3, 4, 5, and 6 in as a list as integers to input to coordinates. And now we see that it doesn't have the decimal points anymore. Now I'll start making the actual linear regression part of the program. I'll make a class called Linear Regression, and it takes in chords. I can make linear regression remember chords by setting self.chords equal to chords. For the steps to do regression, I found instructions for manually calculating regression on statology.org. And it says that the first step is to find the x times y, the x squared, and y squared for each coordinate point. I'll be making a list for each of these to store the information. The second step is to find the sum of the x coordinates, y coordinates, x times y, x squared, and y squared. I'll be creating a function doing both step 1 and 2 at the same time, since I think it'll be more efficient that way. I'll first create all of the lists, and that will be self.xy list, self.xx list, and self.yy list. And the lists are all empty for now. Then I have to make the sums, which I'll abbreviate to SS. So that is self.ssx, ssy, ssxy, ssxx, and ssyyy. And these are all set to 0. Now I just have to go through each of the coordinates, and to make things easier, I'll make the 0th element equal to x and the first element equal to y. For each of the lists, I will have to do something like self.xy plus equals a list containing x times y. And for the sums, I'll do something similar, but instead of adding a list containing the values, I'll just increase the value of the sum by, for example, x plus y. So now that I have all of the lists and the sums, I'll create a checker function that just prints out all of the lists and the sums. It will first print check start so that I know where to start looking, and then it will print all of the lists and sums, but actually in between the lists and the sums, I'll make it print an ellipses just so it's easier to look at. And after all of that, it'll just print check end. I'll make it so that when linear regression is initialized, the function step 1 and 2 is run, and then checker is also run. And to test this, I'll make LR equal to linear regression, and I'll give it the same values as the ones on the statology website, so I can see if all of my values are right. And to do that, I'll run input to coordinates and manually give it inputs. Now I just have to copy this, and I will make it equal to L1. I can give L1 as the coordinates, and if we run the program, it prints all of the values, so I'll check them. I'm done with the check, and all of my values look right, so I'll move on to step 3 and find B0. I'll create a new function called find B0, and it looks like I just have to make self.b0 equal to the formula on statology. There is a new variable called n, and in the example it is 7. And the website doesn't actually say what n is, but I think it's safe to assume that it is the number of coordinates. I'll just add self.n is equal to len self.chords to the very end of step 1 and 2. I'll also make checker print the value of n, and I'll just continue working on B0. I have finished the formula for B0, so I just have to add B0 to checker, and I am getting an error message because there's no B0. I forgot to run find B0 in init, so now it should work. It's still not working, but I think I can fix this by running B0 before I run checker. So now that B0 is working, I'm going to do the next step, which is finding B1. I'll do this in find B0, and I'll change the name to find B0 and B1. I'll just do the same thing I did to B0. And I'm seeing that the denominator for B0 and B1 is the same, so I'll just calculate self.d and then calculate B0 and B1 using d. And this should now be it, so I'll add d and B1 to checker. B1 is all good, and d is also probably good, because B0 and B1 are same as what's on statology. We have all the variables now, so we just have to make the equation, which is predicted y equals B0 plus B1 times x, and the y with the caret symbol on top just means predicted y. And I will create a function called estimate y, and it returns the predicted y given the x. And I should probably have made this predict y instead of estimate y, but this is just a voiceover and I can't change what I wrote in the video. And estimate y is just going to return self.b0 plus self.b1 times x. And also, I'm going to get rid of checker since I know that step 1 and step 2 and also find B0 and B1 are both working. I will estimate the y if x is 210, and I got 74.8. And this is a pretty good estimate since when x is equal to 212, then the y is 75. So since 210 is really close to 212, then the x's should also be similar. But anyways, that was it for this video, and I'm sorry for not uploading last month. I had a lot of things to do, and I will make an extra video pretty soon to make up for the missed upload. And as always, the code can be accessed in the description and also on my website, mathkimchi.org. Thanks for watching. Bye.